Hello, everyone. Welcome. My name is Zhao. Today we study the course Calculus and Vectors. Graphing of rational functions. And comparing a rational function and its reciprocal function. The original function is Qx. Qx equal 2x minus 1 over x squared minus 2x minus 3. And the reciprocal function px equal x squared minus 2x minus 3 over 2x minus 1. There are two questions here. Number one, determine the equation of asymptote, including the vertical asymptote, horizontal asymptote, and oblique asymptote. B, graph the functions. Next, I will explain in detail. At first, we analyze the first function. Qx, the numerator is linear, the denominator is quadratic, so we try to factor the denominator. So the denominator we can factor and write to x minus 3 times x plus 1, right? The top, the numerator is the 2x minus 1. Then we check the denominator. We can get the 2va. If the x minus 3 equals 0, that is x equals 3. If the x plus 1 equals 0, that means x equals negative. So the HA, the horizontal asymptote, is y equals 0. Next we will scratch, we have find the x-intercept, y-intercept. We find the x-intercept, set the Qx equals 0. If Qx equals 0, the numerator is 0, right? 2x minus 1 equals 0. Then x equals 1 over 2. This is x-intercept. Right. Next, we find the y-intercept. Because when y-intercept, that means x equals 0, then we know the y value is 0 minus 1 and the numerator. So 0 minus 1 is negative 1. And the numerator is 0 minus 0 minus 3, so negative 3. That means it's 1 over 3. It's 1 over 3 is y-intercept. Okay. To find the derivative. The derivative of the Qx equal, use the quotient rule. So denominator is x squared minus 2x minus 3 squared. And the numerator is, and then simplify. So we get the derivative of Q equal, after simplify, we get the derivative of Q is negative 2 x squared minus x plus 4 and over x squared minus 2x minus 3 squared. And we can see the denominator is square, so it's always positive. And then we discuss the numerator. We can set y equal to negative 2x squared minus x plus 4. So we just take the y equal x squared minus x plus 4. Okay, this is quadratic. And we can find the vertex and the change in the vertex form. It is x minus 0.5 squared because negative 1 in the middle term, so negative 1 over 2 is negative 0.5. Okay, and then make a complete square and minus 0.5 square, and then copy the 4, and y is equal x minus 0.5 square and plus 3.75, right? So we know the vertex is 0.5 and 3.75. And then we know the vertex in the first quadrant, right? So that means x squared minus x plus 4 always more than 0, right? And consider the derivative of qx, the numerator, the negative. So that means the derivative of qx is less than 0. Then the original function is always decreasing, right? Decreasing for all x, except x equal the VA is negative 1 and x equal 3, right? So we can make a table and identify the sign for everyone when negative. And when x more than 3, so all factor is positive. So finally, the y value is positive. Okay. Then we can graph. So at first VA at the x equal negative 1, x equal 3, the VA x equal 3 and x equal negative 1. Then x-intercept is 0.5. Y-intercept is 1/3. Then we use the table identify when x less than negative 1 at the left side, so qx is negative, so below the x-axis. And then because the HA y equals 0, so at the left side, left end, the close to close x-axis, and the right side is close to close negative 1, negative. So the graph is sketched like that. And in the middle, we know the separate is 0.5, right? And x less than 0.5, the y is positive, and then also plus y-axis. So we get the connected two point x-intercept and y-intercept. So after x more than 0.5, we can see the y value is negative. So it seems like that. And then x more than 3, its y value is positive. So it's above of x-axis, right? So the graph like that. We can see that there are two ends. The left side, when x approach 3 plus, so y approach positive infinity. And the right side, when x approach positive infinity, y approach 0 plus, right? Right? And the graph like that. Px. The function Px is the reciprocal of Qx. This is x squared minus 2x minus 3 over 2x minus 1. So we can factor the numerator. It is over 2x minus 1. At first, we find the VA, check the denominator. 2x minus 1 equals 0. Then we get the x equal 1 over 2. This VA. They are OA. Then we can use long division. And we write down the question form for Px. We get the question here, 0.5x minus 0.75 and minus 3.75 over 2x minus 1. Then we know the OA. That is the quotient, right? Okay, then for the function, we have VA and OA. Next, for graph, so we have find x-intercept and y-intercept, right? That means when y equals 0, that's Px equals 0, we just check the numerator. If x minus 3 equals 0, so that means x equals 3. If x plus 1 equals 0, we get x equals negative 1. That is the x-intercept. Right? Next, when x equals 0, so put in the Px. So we get the denominator 0 minus 1 is negative 1. That means equal 3. That is y-intercept. Right? Okay. And we notice the VA and OA. No HA. Okay. Then we graph. Aubrey asymptote is y equal 0.5x minus 0.75 when x equal 0 is y equal negative 0.75. And the VA x equal 0.5. Vertical asymptote. Yeah. Let me check the left side of the curve. Left side pass through negative 1, 0 and 0, 3. right? We can see the left branch, the left side. When x approach negative infinity, y approach 0.5x minus 0.75. The right side, when x approach 0.5 negative, y approach positive infinity, right? Oh, and then right side is pass through 3, 0. And it's a curve like that. And the left branch, the left side, left end, when x approach 0.5 positive, y approach negative infinity. And the right side, when x approach positive infinity, y approach 0.5x minus 0.75. And next, I will show a video to use DESMOS to show the graph. At first, I explain the function qx. Qx equal 2x minus 1 over x squared minus 2x minus 3. I set the denominator x squared minus 2x minus 3 same. If the numerator is changed, then the function is set the parameter b. Fs equal 2x minus b over x squared minus 2x minus 3. And we check the denominator. If set the denominator equals 0, so we have 2VA. First one is x equal negative 1. Second one, x equal 3. Yeah, this is x equal negative 1. This x equal 3. Just the change for the numerator. And the HA is y equal 0. This S, right? Because the exponent, the numerator less than denominator, right? And we see the change after a fixed b. You see the b change here, the b equal negative 3, the graph like that. There are 3 different curves, right? And the change b. Here, if b equal negative 1.145, the x-intercept negative and the y-intercept also negative. If the b equal 1, so we have the x-intercept is 0.5 and the y-intercept here is 1 over 3. Here, this y-intercept. Yeah, this the graph is the graph like that. The qx, right? Qx equal 2x minus 1 over x squared minus 2x minus 3. Next, this is px. Px equal x squared minus 2x minus 3 over 2x minus 1. We want to know how to change for the graph under same denominator, 2x minus 1. I just change the numerator, set a parameter to y equal a times x squared minus 2x minus 3 over 2x minus 1. That is the y equal 2 times x squared minus 2x minus 3 over 2x minus 1. Keep the denominator same. Then the VA is same, right? VA is x equals 0.5, this red line. And then their OA, right? Because the exponent, the numerator more than denominator, their OA. And we change A. We showed how to change for the OA. Yeah, here the VAX equals 0.5. And A is changed. Yeah, this is curve for the parabol curve. A, after OA change, the curve is changed because the curve cannot touch OA. Okay, if enlarged, it cannot touch. Okay, and if the constant term for the numerator is same, so y-intercept is same, right? Here the y-intercept is 3. Here is 3. And here I said the A is from 0 to 1. The curve like that. If A equals 0, there's no OA, it's the HA. Here the A is positive. Is to 1 here, A equal 1. If A is negative, here, -1, so the OA is decreasing, right? Okay, change. So we can see the y-intercept still same, 3, okay? Right, here, A equal 1. Then is y equal 0.5x minus 0.75. This OA, okay, oblique asymptote. And the curve cannot touch the OA, cannot touch the VA also, right? -1 here. And the -1 and 3 is as intercept. The y-intercept is 3. Then the function becomes PS is 1 over QX.